Hello, my name is Nurul Aini Izzati binti Muhammad Zaki. My ID number is 20206278848. So, in this video, we will learn differentiation in kinematics linear motion. So basically, this is our learning objectives. So the first one, let's start with the relationship between displacement function, velocity function, and acceleration function. So what are the relationship between those three? So let's get started with the definition first. So displacement as of a moving particle is a function of time t. We can call it as equal to ft. And also, when we differentiate it, we will call it as a rate of change of s with respect to t, which is ds per dt. And also, the second one, velocity function of particle at time, which is equal to f equal to gt, which when we differentiate displacement, we will get velocity, which is v equal to ds per dt. And the third one, acceleration function, which is rate of change of velocity with time, which is a equal to ht. So what are the connection of these three? So this is the connection. So to find velocity, you have to differentiate s, and to find a, you will have to differentiate v, or you can also differentiate 2 times of displacement. This is the one, this is the relationship. So at where we can apply this relationship? So let's get started with the example given. So the equation is determine the velocity function v and acceleration function of the particle. Okay, so as I said before, the relationship is when we want to find v, we just have to differentiate s. So the given function is s equal to 3 plus 2t minus t square. Then just differentiate ds per dt. So you will get v equal to 2 minus 2t. And also the acceleration, you just have to differentiate 2 times of displacement, which is s, or you can just use the v function and differentiate it as usual. So we will get a equal to negative 2. So this is the information. A equal to negative 2 means the particle is moving with a uniform acceleration of negative 2 ms negative 2. Okay, so the next question is on the same diagram. Sketch a graph of functions s, v, and a. Okay, so this is the graph we have found about the displacement over time, and also this is the number line. Okay, so from the graphs and the number line, so we have found this, which is the displacement of the particle at t equal to 0, which is this one, t equal to 0, from the fixed point 0 is 3m. This is the one. So, okay, and the initial velocity is 2 ms negative 1. This is the one. And the acceleration is negative 2 ms negative 2. Okay, and at t equal to 1, which is this one, the particle changed its direction. The displacement from the fixed point 0 is maximum, which is 4 meter. The velocity is 0 ms negative 1, and the acceleration is negative 2. Okay, so it is still the same, and this one and 4. Okay, so at t3, which is this one, the particle reached to the fixed point 0, where its displacement is 0 meter. This is the one. Okay, so the blue one. Velocity is negative 4 ms negative 1, which is this one. And its acceleration is the same, which is negative 2 ms negative 2. So as you can see, and we can find that the total distance traveled by the particle from t0 until t equal to 3 is, so this is sm. So as you can see by this number line, you can see that we started with 3 from t equal to 0 seconds. Okay, so as you can see, we started from t equal to 0 at 3 meter. So the particle moves from 3 to 4 and to 0 point, which is from 3 until 4 and then go back to 0. So what can you conclude here is you can find the total distance, which is the particle move from 3 to 4, which is equal to 1, and then the particle moves from 4 meter to 0 fixed point, which is this one. So it is 4 meter. Okay, 4 meter. So 1 plus 4 is equal to 5 meter. So this is how you can find the total distance. It's easy, right? Okay, so the exercise is given to determine the velocity function v. So as I said before, to find v, you just have to differentiate s. Okay, so just differentiate it, which is v is equal to gt. Okay, v is equal to gt, and also as given is this, so just differentiate s, ds per dt. Okay, so you will get 16 minus 2t. This is it. Simple, right? Okay, so the number 2, you just have to differentiate 2 times. Am I right? So a is equal to dv per dt and equal to d square s over dt square. First, we will have to find v. Okay, so it is 3t square minus 10t. So a is equal to 6t minus 10. So this is the answer. Simple, right? So don't forget the unit, ms negative 2. As simple as that. Okay, so the next objective is determining and interpreting instantaneous velocity of a particle from acceleration function. Okay, so this is the question. Can you determine the instantaneous velocity of a particle at any time? So let's understand this first. V is the gradient. Gradient is velocity. Okay, so to find the gradient, you have to differentiate the s function. So when you differentiate the s function, which is s, okay, which is the function, you will get this. So to find the gradient, you just have to insert the t in the function, which is when t is equal to 0. When t is equal to 0, then gradient is equal to 40 minus 10, 0. So you will get 40, and the same with the others. Okay, so each of the gradient of the tangent is as ds per dt at t equal to 0, t equal to 4, t equal to 8, and t equal to 10 obtained, we will call it as instantaneous velocity. So this is the graph. Okay, as you can see, this is the graph. We will find this is the gradient. Okay, this is the gradient. Okay, For the displacement time graph in the shape of curve, the instantaneous velocity is different at every point of the curve. As you can see, we get a different value, is it? How to find initial velocity? So when the time t is 0, as simple as that. Okay, so at t equal to 4, okay, what does it mean by that? Which is when the displacement is maximum or even minimum, so the gradient of tangent, or we call it as the instantaneous velocity, is 0, which is v equal to 0. So as you can see, the tangent is the same. Okay, so it is the same, so we call it as constant velocity. So you can find instantaneous velocity by differentiate the displacement function, which is, as you can see, this is the one. So v is equal to 40 minus 10t. So you differentiate as, you will get this. Okay, so when you insert t is equal to 4, the velocity v is equal to 40 minus 10t. So this is how we can prove that we got constant velocity. Okay, so the instantaneous velocity at 4 seconds is 0 ms negative 1. So in general, what can you conclude from this? So to find instantaneous velocity, you just have to substitute the value of t in the velocity function. That is what we call as instantaneous velocity. Okay. Okay, so the next example, a particle moves along a straight line. So they want us to calculate the initial velocity in ms negative 1 of the particle, the instantaneous velocity. So let's start with A first. Okay, so when displacement of function s t3, so it's given, so we can find it v by differentiate s, we will get 3t squared minus 18t plus 24. As I said before, to find initial velocity, t must be 0. So as it done by this, you just have to insert 0 in velocity function. So you will get 24. Okay, the next one, the instantaneous velocity in ms negative 1 at 3 seconds. So just the same. Just insert 3 in velocity function, which is this one. Okay, and then you will get v is equal to negative 3 ms negative 1. Okay, as simple as that. Okay, and the next question. So what can you conclude from this? The key is at rest. So when the particle is instantaneously at rest, it means v is equal to 0. Okay, so you just have to use the velocity function and you equal it to 0, just like this. Okay, equal it to 0, and then you just have to insert it in your calculator by using EQN, and then you will find the values of t, which is this one. See, this is t, sorry. So t is equal to 2 seconds and 4 seconds. Okay, and the last one, the range of t in seconds when the particle moves to the left. Okay, so what does it mean by the left? So when the question mention leftwards, you will know that the v is less than 0. Am I right? So when it is right, v is more than 0. When it is mentioned as left, then v is less than 0. Okay, so as I said, less than 0, and then you just have to find just the same. Okay, by using the EQN and insert it in your calculator, then you will find that t is more than 2 and t is less than 4. Okay, so this is the graph. By using the graph, okay, so this is the exercises. Okay, the question gives us the displacement function, and then they want us to find the instantaneous velocity when t is equal to 2. So just like I said before, to find the velocity, you just have to differentiate displacement. Okay, so v is equal to s per dt, then you will get, okay, so when t is equal to 2, just have to insert the t values in v function. So v is equal to 6 2 square minus 10 2 plus 4, as easy as that. And then you will just have to calculate by your calculator, and then you will get 8. So it is v is equal to ms negative 1, as simple as that. Okay, so let's move on to the b. So as I said before, so the question before is at rest, am I right? So this question is at stop, so stops is the key. Okay, so it means that v is equal to 0. The v function 6t square minus 10t plus 4 is equal to 0. Then you will have to insert it in your EQN calculator, and then you will get t minus 1 and 3t minus 2 is equal to 0. Okay, and then you know that hence the particles instantly stops at s equal to 2 per 3 and s equal to 1, the v more than 0. Okay, so just the same, use the function given. So 6t square minus 10t plus 4 more than 0, then you will get as simple as that. And then okay, so this is the critical moment when you have to find either it is or it is and. Listen carefully. Okay, so how to do the graph? Okay, for me, I used to like to use the number line, so let me take you that one. Okay, so this is your line. Okay, so as you can see, 2 per 3 is less than 1. This is 1, this is infinity, this is negative infinity. So you just have to insert the values which is more than 1 in the function given. So as you can see, you will insert 2. 2 minus 1 is positive, 3t minus 2 is positive 2. So this is positive. Okay, so 2 per 3 and 1. So when you insert 0.8, so 0.8 minus 1, 0.8 3 times 0.8 minus 2, you will get negative. You can insert 0.5. So 0.5 minus 1 is negative. 0.5 times 3 minus 2, you will get negative. Get negative, so it is positive. So as you can see, this one is positive, this one is positive, so it is this one and this one. This is when we get it as O. Okay, O. So it is t more than 1 and t less than 2 per 3 and more than 0, more than or equal to 0. Why more than or equal to 0? Time cannot be negative. Okay, so the last one is we want to find the acceleration of a particle from velocity and displacement function. Just like from the previous one, which is when we call it as a ds per dt, it is instantaneous velocity, and it is the same with acceleration. So this is the one, dv per dt, and also d square s per dt square. So this is the graph. Okay, so on the velocity time graph, this one, okay, you will know that the gradient at any point on the graph is the same. So this one, okay, it is linear graph, am I right? So that's why the gradient is the same. So as we know, the gradient is the same, then the dv per dt is also the same. Thus, the particle is said to have uniform acceleration. So when the gradient is the same, the dv per dt is the same, then the uniform acceleration is the same. You have to remember that. Okay, so this is what we call as constant acceleration. Okay. Okay, so in the diagram for the time interval t is more than 0, which is this one. Okay, v is increases with time, so we can conclude that acceleration is positive. So for the interval a to b, what can we conclude from this? Okay, so when v is increases with time, it does mean that a is positive. When v is decreases with time, we can call it as a is negative, and it is called as deceleration. As simple as that. Okay, so at point A, the particle experiences a maximum velocity, which is this one. Okay, and it is acceleration. So we can say that this is maximum velocity because it is the highest one. So A is the highest one, and its acceleration, this point is 0. So we know that when V is at maximum, then A is 0. Okay, and you have to know that when A is 0 is not the same with V is equal to 0. It is different. When V is 0, we call it as the particle is at rest. When we call A as 0, A is 0 is not the velocity is not the rest, but the velocity is maximum. Different. Okay, so the velocity is either maximum or minimum. So the conclusion is, when you want to find instantaneous acceleration, you just have to substitute the value of t into the acceleration function. Okay, so let's take a look at the example given. Okay, so this is the one. Okay, and then so when you call it as initial acceleration, so it's just the same with initial velocity. So to find both of them, t needs to be 0. Okay, so the next one, just have to insert t values, which is 5 seconds, in the acceleration function. When the particle passes through 0 again, it does mean that s is equal to 0. Okay, you just have to remember the key of the question, t values. So you will get t is equal to 0, t is equal to -1, and t is equal to 4. So we use t is equal to 4. Why we cannot use the -1? Because time cannot be negative. Okay, why we don't use the 0 value? It is because of when the particle moves, it is t equal to 0. We want it to pass through point 0 again. Just insert the value of t in acceleration function, then we will get 18 ms -2. So what does it mean by positive? So it is just the same as when the left, the right. Okay, if then a is more than 0. So this one, so use the acceleration function, then you will get t is more than 1. Okay, let's do the exercises given. So when a is 0, they want us to find t. Okay, it gave us v. We don't have the acceleration function yet. Then you just have to differentiate velocity function. Then v is equal to the v per dt. Okay, you will get 2t minus 2. So when it comes to a is equal to 0, so you just have to include 0 is equal to 2t minus 2. As simple as that. Okay, and then you will have to find t. Okay, so 2t is equal to 2, t is equal to 1. Okay, so b, what it takes when the particle decelerate. So it does mean that a less than 0. Okay, so the question wants us to find the range of values of t. So as simple as that, a less than 0. We just have to put the acceleration function, which is 2t minus 2 is less than 0, 2t less than 2 and t less than 1. Okay, so that is the lesson of in this video. To find the velocity function, you just have to differentiate displacement function, and to find acceleration function, you just have to differentiate velocity function. As simple as that. Okay. Okay, so the next one, to find instantaneous velocity, it is easy. You just have to substitute the value of t in the velocity function. This one. Okay. Okay, and the last one. Okay, from this, just the same as instantaneous velocity. To find instantaneous acceleration, you just have to substitute a value of t in acceleration function. So that's it for my video. Thank you so much for watching, and thank you so much for listening.